You want to get closer? Okay. Today we're going to look at molar masses for compounds. You guys reviewed molar masses for elements and formula masses for elements on Thursday. Anyway, so let's talk about the number of atoms of any particular element that you have in a compound. This should also be reviewed, but I figured it's better just to talk about it. If you have water, the formula is H2O, the subscript 2 means that there are 2 hydrogens. There is no subscript by the oxygen, and whenever there's no subscript and there's an element written, you assume that there is one of those elements. So water is made of 2 hydrogens and 1 oxygen. Okay, here we have barium sulfate, BaSO4. That means with no subscript, with barium we have 1. With no script by sulfur, although we do have a smudge on the paper, we have 1. And there is a subscript 4 by oxygen. The subscript 4 only refers to the oxygen and not to the sulfur and not to the barium. Here we have something more complicated. It's calcium nitrate. You can, with the formula Ca, open parentheses, NO3, close parentheses 2. You can think of this formula as looking like this. 1 calcium with 2 nitrate or Na3 groups attached to it. If you like visualizing this better, like this, go ahead. We would always write it like that, never like this, but it's a good way to think about it. So we're looking at this. There's a single calcium because there is no subscript by it. So we have 1 calcium. Now we have to look at this nitrate group, this NO3 group in the parentheses. This 2 outside the NO3 group, outside the parentheses, refers to everything inside the parentheses. So it's saying take everything inside here and multiply 2 by 2. That means we had 1 nitrogen inside the parentheses, we multiply by 2, we end up with 2 nitrogens outside, or totaling them. We have 3 oxygens within the parentheses. The subscript 3 refers only to the oxygen, not to the nitrogens. So 2 times 3 is 6 oxygens. Now, if you go down here and look at my little drawing, I have 1 calcium, 2 nitrogens, 3 plus 3, 6 oxygens. Okay, if we have a coefficient, the number in front of a formula, say 3 calcium nitrates, we're going to multiply all of the atoms by 3. So you would go through everything we did here and then multiply by 3. And so this formula has 1 calcium in it, so we need to multiply by 3. So we have 3 calciums. There were 2 nitrogens. 2 times 3 is 6 nitrogens. There were 6 oxygens. We need to multiply the 6 oxygens by 3. That gives us 18 oxygens. Okay, that's because of this coefficient. If we add these up, 3 plus 6 is 9, and another 18 is 27 total atoms. So we have 27 total atoms, here. Now, let's talk about masses. Molar masses and formula masses, and we're going to need to look at the periodic table for that. If you have 1 water molecule, okay, remember to use the periodic table, 1 water molecule has 2 hydrogens. 1 water molecule has 1 oxygen, so that's what the 2 and the 1 are talking about. If you look at the periodic table, the atomic mass of hydrogen is 1 atomic mass unit. So 2 times 1 AMU gives you 2 AMUs. If you look at the periodic table, rounding to the nearest tenth, we're not going to write down 15.997. We're just going to use 16 for oxygen. There's only 1 oxygen times 16 atomic mass units is going to give me 16 AMU. And the water molecule is going to be 2 plus 16 or 18 AMU. So all we're doing is finding the mass of each element, counting up how many atoms of those elements there are, and adding them together. Now, that was atomic mass or formula mass. Okay, atomic mass is for a single atom, formula mass is for a molecule. If we want the molar mass, if you remember from the review video the last time, the molar mass is numerically the same, but the units are different. So the molar mass of water is 16 grams. Excuse me, 18 grams of water in 1 mole. Let's try another one down here. Let's look at barium sulfate. Barium sulfate, or barium, there's one barium atom in barium sulfate. Its molar mass, or its atomic mass, is 137.3 AMU. Sulfur is 32 AMU, and we have 4 oxygens. They're each 16 AMU. 4 times 16 is 64. If we total these, we total the 137, the 32, and the 64, we get 233.3. Now that's either 233 AMU, atomic mass units, if we're talking about molecules, or 233.3 grams for a mole. So again, numerically the same, units are different depending on what we are talking about. We're going to be using molar masses here, so you want to think in terms of grams. Now, we had that little diamond-shaped chart a while back. Okay, and there's just been one minor change to this. If you didn't write down the chart, well, you probably wrote it down before, you might want to redo it. Remember, going from grams to moles to molecules, or molecules to moles to grams, we just follow the arrows. It was the no thinking method that we came up with last time. Okay, grams to moles, you divide by the molar mass, or the atomic mass, but now we're working with molar masses. Moles to molecules, you multiply by Avogadro's number. Going the other way around, we divide by Avogadro's number going from molecules to moles, and we'd multiply by the molar mass going from moles to grams. The difference in the chart is the bottom of it now says molecules, it's not atoms. Your old chart had atoms on the bottom. This one has molecules. So how do you get to atoms? That's the tricky part. If you want to go from molecules, which you will mostly be solving for in this chapter, to atoms, you've got to count up how many atoms of every element you have. So if we look at barium nitrate, there's one barium atom in a molecule. There are 2 nitrogen atoms in a molecule, and there are 2 times 3, or 6 oxygen atoms in a molecule. That tells me I have 9 atoms per molecule of BaNO3, So if I have 5 molecules of barium nitrate, I'm going to take that 5 molecules, and I have to multiply by 9 atoms per molecule. The molecules cancel, and you're left with 5 times 9, or 45 total atoms. If we're dealing with a more realistic number, 3.01 times 10 to the 23rd barium nitrate molecules, half a mole, we would still multiply by 9 atoms per molecule. 3.01 times 10 to the 23rd multiplied by 9, molecules cancel, you're left with atoms, and you have 2.709 times 10 to the 24th atoms. So you need to be able to count up the number of atoms you have in any given molecule. It might ask you how many barium atoms you have in this many barium molecules. It would just be 1. If they asked you how many nitrogens they had, well, you have 2 nitrogens per molecule, so it'd be 6.02 times 10 to the 23rd. If you were just asked how many oxygens, it would be 6 times, because we have 6 oxygens, 6 times 3.01 times 10 to the 23rd, which would be 18.06 times 10 to the 23rd, or 1.806 times 10 to the 24th. Nobody heard anything I just said then, but remember, either do the total number of atoms in a molecule or figure out how many of each type of atom you have and multiply by that. Okay, we're going to practice that. So that's it.